arrived to document 4, chapter 9, function of neurons, and document 4, sensory receptors and nerve message. In this document, after the introduction, first we'll classify sensory receptors, and we'll use two different criteria to classify them. Then we'll recognize only, we have to recognize three types of potentials, and at the end, the last objective, third objective, that is extremely important, is to understand how is nervous message coded in a sensory receptor or in a neuron in general. So we want to speak about sensory receptors. Yes, we saw this word before. Wallah ya jama'a. Bala at the beginning of the chapter. At the beginning of the chapter, we said that sensory receptors are called also what? Who can tell me what is the other name of sensory receptors? Rawa, sense organs. Very good. Sense organs. Sense organs. Very good. Do not forget, ya hubbi. At the beginning of this chapter, we said that the encephalon receives the central nervous system, that is made up of two centers, receive from the sensory receptors, they receive informations. Very good. Sensory receptors take the information from the environment or from anywhere, and the information is transported towards the central nervous system that will analyze, will interpret, will deduce will conclude something, and will give answers. The answers are transported toward what? Very good. The effector organs. Yes. The effectors as the muscles of the tongue, the glands, etc. The effector organs receive the answer from the spinal cord. Now, this way of opposite directions, it is realized that the transport of information from sensory receptors toward the central nervous system, or the transport of answers from the central nervous system toward the effector, is realized by, very good, the peripheral nervous system, that are the nerves, cranial and spinal nerves. Yes. So, sensory receptors have the role to take information, and the information must be transported toward the central nervous system. Okay. Now what? Sensory receptors, in reality, can be classified based on two different criteria. They are first classified based on the origin of the information, or the second criterion, the nature of the information. Let us tell you what. Based on origin of the information, it says, what is the meaning of origin? من وين جاي هذه information? From inside my body or from outside my body? This is the question. I have pain in my stomach. Information from inside my body. Okay. There are clouds in the sky. Information from outside the body. So, basing on the origin of the information, the sensory receptors are classified into interoceptors, from inside, internal region of the body, inside the body, interoceptors. Sometimes we say interoreceptors. Yes, why not? And very good, exteroceptors or exteroreceptors. That's it, based on the origin of the information. The second criterion, it is about the nature of the information. Nature. It is important to understand what about the nature of the information. Yani it is about light, or it is about pressure, or it is about temperature, the nature of the information, and not the origin. Basing on the nature of the information, there are 5 types of receptors. Nature of information or nature of stimulus, type of receptor, yani what what name we give to this receptor, and where does it exist, in which organ, in which sensory organ. It's not to memorize. It is good to recognize something about the name, especially about the name type and about the type of receptor. Now what? Nature of stimulus: touch, pressure, stretching. They are physical or mechanical, isn't it? Information. So the type of receptor is called mechanoreceptors. Where do these receptors exist? Touch, عم بقول لك touch, pressure, stretching, skin, طبعا skin, the muscles, of course, the blood vessels, etc. Skin, especially, it's not to memorize, as I said. In the skin, there are touch receptors. I can touch my hand. I can touch the table. I can feel it. Okay, it's smooth, it's rough, etc. The pressure, if I make a pressure, and I showed you the pressure given made by the ball, if you remember, by the experiment on the hand, stretching, etc. The second nature or information or stimulus is the temperature variation. Thermoreceptors or thermoceptors, why not? They are sensitive to the change in temperature. In the skin, in tongue, yes. Thermoreceptors or thermoceptors. Now, in the skin, as you see, please pay attention. There are receptors called mechanoreceptors, and there are receptors called thermoreceptors. It means that if I apply a pressure on my skin, the mechanoreceptors will work. Thermoreceptors will not be stimulated by the pressure. While if I put droplets of hot water on my skin, mechanoreceptors will not work. They are the thermoreceptors. They are different. So different types of feelings necessitate different types of receptors. It's important. Okay, حبي مش same sensory receptor will be stimulated with any type of stimulus. لا. Mechanoreceptors in the skin will only take the information about the pressure on the skin. The thermoreceptors will take only information about the temperature on the skin, etc. Now, the third type of stimulus, nature of stimulus, light, photoreceptors in the eye. Pain stimulus, it's important. And we'll see later what is the meaning of high pressure and high temperature, etc. Or bright light, for example. Bright light also will cause the pain. What is important for me, pain stimulus, the receptors transporting pain are called nociceptors or nocireceptors in the skin, in muscles, and etc. We'll see this later. We'll study nociceptors or nocireceptors in details later. Now, transported molecules, the chemoreceptors, the transported molecules in the nose and on the tongue, chemoreceptors, they are sensitive to the chemical substances. They exist in tongue and nose. It is a general view on types of receptors based on the nature of the stimulus they are sensitive to. In order now to continue our study, and here you should pay attention more. We have an experiment as it's shown in this document B. Here we have a container where we put a mechanoreceptor. It is a neuron. Look to this. The sensory receptor is a neuron. Look to this. This is the axon, and here we have a myelin sheath. So, but the cell body of the neuron changes to be adapted to the nature of stimulus it will receive. So it is a neuron. It is a mechanoreceptor. How I know it? Because we are applying a pressure on it. We are applying a pressure, and it is stimulated by pressure. It is a mechanoreceptor. Now what? As I said, we have this pressure applied on the cell body, and we have 3 oscilloscopes. Please pay attention. This is the recording electrode of the first oscilloscope at the level of the cell body. The second oscilloscope is inserted in the first segment of the axon, implantation cone, or the first segment of the axon. the few millimeter, the first segment of the axon, and the third oscilloscope is connected in the axon, to the axon, not first segment and not at the level of the cell body. Upon stimulating this receptor with an effective intensity, we'll observe three different recordings. Look to this. The first oscilloscope that is inserted into the, or at the level of the cell body, is recording a potential. We will call it receptor potential. Please, receptor potential. It says what? What is a receptor potential? It is the potential observed or recorded at the level of the cell body of the neuron. Okay, receptor potential. Now, the potential recorded by the oscilloscope 2, or having the recording code R2, it is called, in the first segment of the axon, it's called generating potential. Generating potential, it is the potential recorded at the beginning of the first segment, small fragment, small part, very small part of the axon. And of course, the recorded potential at the level of the axon is called, yes, action potential. We know it. Now, please pay attention. Receptor potential is not similar to the action potential. We studied action potential very well, huh? It's not similar. The receptor potential, look to the shape of the recording, huh? Is not similar at all to the action potential. Also, the generating potential is not similar. Look to the generating. It does not reach to zero. It does not arrive to zero. While the action potential will arrive till 30 to 40. Plus 30 to plus 40. Do you remember? Very good. So, for this, we can say that we have three different types of potentials. The action potential at the level of the axon, and we studied it, and it is what is important for us. In our curriculum, we need to study action potential and electric potential only. Generating potential and receptor potential only, you should note that receptor potential is the potential recorded at the level of the cell body, and generating potential is that recorded at the first segment of the axon. Now, but let me tell you something. Once we have generating potential, it means necessarily we will obtain an action potential. Yani, if no receptor potential, no generating potential, and no action potential. If there is a receptor potential, we will obtain generating potential and we will obtain action potential. They are linked together. Okay? Only this you should put in your mind, this only. So, the generating potential is a receptor potential that is strong enough to produce an action potential. So, it means that only, please pay attention for my words, that if there is regenerating potential, it means that we will obtain an action potential. Not more than this, I swear. Okay? Good. But only memorize this. If I ask you, what is the name of the potential, okay, generated at the first segment of the axon, you will name it generating. At the level of cell body, it is called receptor potential. And what is the name of the potential recorded upon stimulating the neuron? And at the level of the axon, it is called action potential. Okay? Now, I will keep this document, but I will put the most important part of our study in document 3 here. Please. Here, in reality, this is what is interesting, what is important to us. Here we arrive to the most important part of this document. In reality, in this document only we named two types of receptors, okay, based on two, we classified them into intero and extero receptors, based on the origin of the information, and 5 types based on the nature of the stimulus. And we saw that there are receptor potential at the level of cell body, generating potential at the level of the first part of the axon, and action potential at the level of the axon. We know this. But now, something to understand very well. I will put here 3 recordings. The first is P. P means pressure. When we stimulate, okay, we obtain a recording of the intensity of the pressure applied. Okay? Now, the pressure, the first simulation with a pressure of approximately 0.8 gram per centimeter square. The second pressure, look, is about 2 approximately, or 1.8 gram per centimeter square. The third is approximately 3 gram per centimeter square. We are increasing the intensity of stimulation. We are stimulating this mechanoreceptor. We are applying a pressure, and this pressure in the first stimulation was approximately 0.8 gram per centimeter square. The second, approximately 2, and the third is approximately 3 gram per centimeter square. Okay? Now, the second part of this document, it is written here. We observe R1. R1 means, what does this mean? R1 means what? Very good. The receptor potential. So the second row represents the receptor potential. Upon stimulating with 0.8 gram per centimeter square, this is the receptor observed. For stimulation with, when we increase the intensity of stimulation to 2 gram per centimeter square, we obtain this recording of the receptor, and so on. The last recording, here we have R3. R3 means what? What does the RC mean? Yes, very good. Look to this. RC, the recording 3, it is for action potential. Now look to this. Instead of drawing the action potential in details as depolarization, repolarization, hyperpolarization, sometimes the oscilloscope can give us one vertical line, and each vertical line represents the action potential. Okay? The vertical line represents the action potential. If we use the low speeds of the oscilloscope, it will give us one line, and every line like this, every vertical line represents an action potential. Now, I will discuss this document with you, step by step and part by part, like this, okay, in a vertical way. Intensity of stimulation, then we'll see the receptor potential, then the action potential, like this. Now, once we stimulated with 0.8 gram per centimeter square, we go towards the receptor potential. If you see very well, if you looked very well, these points represent the threshold of the receptor potential. It means that if the line reaches these points, it means that we have receptor potential. If it is below, it means no receptor potential is obtained. Okay, ya hubbi? Very good. Now, look to this. For the first stimulation, 0.8 gram per centimeter square, no receptor potential. مظبوط الحكي? Look to the recording. Is this below the points? And what? Downward, please. Is there any action potential? لا, yes, there's no action potential at the level of the axon. R3 did not give anything. Yes, you know that, because I said for you few minutes before, and I told you that if no receptor potential, no action potential. If there is receptor potential, we'll obtain action. So in this case, no receptor potential. Okay, few minutes ago I told you that if no receptor potential, will not obtain an action potential. Okay, good. Now, the second simulation. If you look to the second simulation of amplitude of intensity approximately 2.2 gram per centimeter square, what? We have the recording obtained is above the threshold, above this line. It means that we have an action potential. Sorry, 100 millions of times. We have a receptor potential. Look to the shape of the receptor potential. It is bizarre, isn't it? Okay, what is important for us? There is a receptor potential. It's above the line. It says, نعم يا حبيبي. طيب, look to this. Look, please. In the first simulation, the receptor were below the line, يعني no receptor potential. Here we have above. What if, يعني there is a case that is not existing here, isn't it? فكروا أي case is not existing يا شاطرين. Very good يا زكايا. إنه يا أستاذ تحت الخط وفوق الخط فيش مجال يكون على الخط. Of course yes. يعني there is a missing experiment here. يعني we should show you what if, okay, it is just on the line, because the first experiment in your book is below the receptor, is below no receptor potential. Here we have above the threshold, above this line. It means that we have a strong receptor potential, if you want. Now, for this strong receptor potential, look to the action potential. I want before discussing this, I want to show you if the stimulation was giving enough, only just receptor potential, just on the point. In this case, we'll obtain, of course, an action potential. If there is receptor potential, it says لما يكون في receptor potential يعني this blue recording must reach to these points, black points. This indicates that there is a receptor potential. Now, there is a receptor potential, so there is an action potential. Don't forget, every vertical line represents an action potential. طيب. What now about the second stimulation? هلا فيك تسميها third stimulation as you want. لأنه the first below the line, the second exactly on the line, and there is an action potential. It is the third as you want. But what is important for me, the receptor potential here is higher than the threshold. This line, يعني, is strong. Look to the receptor potential. It is something bizarre. It's something not similar at all. يعني, it's not the shape, neither the structure of the potential, the receptor potential. Look to this. The receptor potential increases, the amplitude of the receptor potential increases when we increase the intensity of stimulation. But you know that we are working on a nerve fiber, one neuron. So the action potential does not increase as amplitude, isn't it? Good. So what I want to tell you, and look to the receptor potential, with the increase of the intensity of stimulation, the amplitude of the receptor potential is increasing. Look to this, for example, at the last third stimulation. The intensity of the pressure applied was 3 grams per centimeter square approximately, and look to this increase in amplitude. Then it decreases progressively, gradually. It decreases gradually, then it returns to its normal value, initial value. Okay, good. Now, please stay with me. A question. Is the amplitude of the action potential increasing? Does the amplitude of the action potential increase when we increase the intensity of stimulation? No, it says. We say what? The nerve fiber what? Obeys the law of all or none. Very good. So now it's time to ask me another question. It says, when we increase the intensity of stimulation for a nerve fiber, the amplitude of the action potential does not increase. Okay, على راسي. طيب, what changes? يعني nothing will change? لا, أكيد مش nothing will change. Something will change, but not the amplitude. Okay. So something will change, but not the amplitude. The amplitude will remain constant. Okay, look, let us compare this receptor potential and this one. When there is just a receptor potential on the point, we obtained one action potential. When we increased the intensity of the stimulation and above the point, the receptor, the amplitude of the receptor potential increased. Does the amplitude of the action potential increase? No. So what changed? What increases? The number. Okay. 1, 2, 3, 4, 5, 6. the number of action potential increase and not their amplitude. Okay, I start to understand. So, in our fiber, when we increase the intensity of stimulation, the amplitude remains constant, but the number of produced action potentials as the result of this increase in intensity will increase. When we added just receptor potential, one action potential, this is the minimal intensity. The minimal intensity is sufficient to produce one action potential. Now, when the receptor potential increase following to the increase of the intensity of stimulation, when we increase the intensity of stimulation, the amplitude of the receptor potential increased, and this provoke an increase in the number of action potentials and not the amplitude. And look to this beautiful drawing, please. At this region here, when the receptor potential was at its highest amplitude, okay, the number of action potentials was high, 4. More the amplitude of the receptor potential decreases, more the number per unit of time. It's important, unit of time, time in second, time in seconds. So we say the number of action potentials per unit of time changes. More it is of high amplitude the receptor potential, the number per unit of time was high. What do we name this in physics? Number per unit of time. Very good. The frequency. The frequency of action potentials increases. The number of action potentials per unit of time increases. And when the receptor potential decreases, the frequency, the number per unit of time will decrease. Okay, will decrease. Look to this also. Same idea. When we increase the intensity of stimulation till 3 grams per centimeter square, what? The amplitude of the receptor potential increased. Okay, becomes very high. And what changes there? Very good. The number of action potentials per unit of time increased and not the amplitude. So when we increase the intensity of stimulation, the frequency of action potentials in inner fiber increases and not the amplitude. It's very important. Look to these. Very high number of action potentials per unit of time. And when this line, when the receptor potentials start to decrease, what? The number per unit of time start to decrease also. The main idea I want you to put in your mind, and pay attention if you want. Pay attention, please. The main idea to remember that in inner fiber, when we increase the intensity of stimulation above the threshold, the amplitude remains constant, but that will change is the number of action potential and not the amplitude. Suppose, to finish our study, please, suppose we have only these 3 drawings, this one, and this one, and this one, without observing the intensity of stimulation. Can you tell me where does the intensity of stimulation is its highest value? Very good, I said. Where the number of action potentials is greater, the intensity of stimulation is the highest or the stronger than the other regions. So here it is average, while here it is less than the 2 others. So by observe the number of action potentials, I can recognize where does the intensity of stimulation, or where was the intensity of stimulation high, or where was it was low. Because the amplitude will not change with the intensity of stimulation, but what will change? The number of action potentials. So you will count the action potentials. Where the number of action potentials is higher, the intensity is stronger, and vice versa. We say that, we say what now? We say that please pay attention to this conclusion, and only this conclusion, and we are finished. We have finished. Then, we have finished, please. I will read with you this conclusion. Then in a nerve fiber, when the intensity of the stimulation increases, in a nerve fiber, when the intensity of the stimulation increases above what? Above the threshold. What will happen? The amplitude of the action potential, very good, does not change. Why? But its frequency, يعني the number of action potential per unit of time increases. So when we increase the intensity of the stimulation nerve fiber, the amplitude remains constant because the nerve fiber obeys the law of all or none. What changes the SS? معقول ما في شيء يتغير بلا. The number of action potentials, the frequency of action potentials will increase. We say that, what do we say? We say, please انتبه يا حبي. In a nerve fiber, yes, the intensity of the stimulation is coded, يعني it is translated. It's called, يعني it is translated how? By changing or by modulating. Modulating, يعني changing what? The frequency of action potential and not its amplitude. The frequency of the action potential and not its amplitude. So, if I ask you now, how is the intensity of stimulation translated? كيف تترجم? How is translated? How it is coded in a nerve fiber? It is translated by changing the frequency. When you increase the intensity of stimulation above the threshold, the number of action potential or the frequency will increase. When we decrease it, but it remains above the threshold, the number of the frequency of action potential will decrease. But all the time, they have the same amplitude. All the time, they have the same amplitude, and it is important. Okay? Good. A question, and we have finished a question. Okay, how can you know? What about the threshold intensity, the minimal intensity? How many action potentials we have to obtain when we apply the minimal intensity? 2 or 3? لا, yes, there's 1. Very good. So minimal intensity must produce only 1 action potential. Please pay attention for this. اسمعوا مني. Now what? If I have only the amplitude of the action potential, I cannot know if it is the minimal intensity or not, because the amplitude will not give me an idea about the intensity of stimulation. Why? Because the amplitude will remain the same even if we increase the intensity of stimulation. If it is the threshold or above the threshold, we'll obtain the same amplitude. So in order to know where is the intensity, is the threshold or where is stronger, as I said, I have to count. I have to you to give me, as a teacher, to give me the frequency or the number of action potentials. If you give me the number of action potentials, I can tell you where the intensity is strong, where it is low, and where it is minimal. Once we have only 1 action potential, it means it's the minimal intensity. Where the number increases, it is average. Where it increases again, it is stronger, is the highest intensity of stimulation. For this, we say that like this. Please look to this. The intensity of the stimulation is coded and is translated by what? By modulating, يعني changing. By modulating and by changing what? Amplitude? لا, yes, it is by changing the frequency of the potential and not its amplitude. I hope you understood what I explained today. We finished our document 3. It is good for you, good for us. Hope you study. May God protect you and your family. And see you بإذن الله سبحانه وتعالى. Sorry, I said document 3. It's not document 3. We finished our document 4. Again, may Allah protect you and your family. Please keep at home and please study and I will see you later بإذن الله سبحانه وتعالى.